In this video, I will walk you through a 5 kW off-grid solar system, covering everything from choosing the right components to understanding the costs. We will calculate everything in these 3 simple steps. Then I will give you some more information about the system itself. I'm Nick, author of Off-Grid Solar Power Simplified with over 2,000 reviews. I help people create their own off-grid solar systems. Ready? Let's get started. Solar panels. Let's start by selecting solar panels. For this example, I will use Canadian Solar 400W solar panels to determine how many panels we need. Divide the total solar power, which is 5,000 W, by the power of each panel, which is 400 Ws. You will need 12 solar panels, and we have a total of 4,800 watts. Next, we must calculate the charging current. To choose the right charge controller to find the charging current, divide the total solar power, which is 4,800 W, by the charging voltage of 57.6 volts. This gives us 83 amps. We will use a charge controller rated for 100 A. A good choice is the Victron 450 volts, 100 AE amp charge controller. Almost done. The next step involves calculating the maximum input voltage. When looking at a solar panel specifications, note the open circuit voltage, or VOCC, which is 36.8 volts. We cannot wire all 12 panels in series because the voltage would exceed the charge controller's 450 volt input limits. Instead, split them into 2 groups of 6 panels, each connecting them to the charge controllers to MPPT inputs. Let's check the maximum input voltage. 6 panels, 36.8 VOCC, 1.25, which is a safety factor, equals 276 volts. This is within the upper limit of 450 volts. The startup voltage is 120 volts. We add 2 DC breakers of 20 AIMM each before the charge controller's input to isolate the panels when needed. After the next step, we are going to size an inverter generator. Step 2 is sizing the battery for our 5 kW off-grid solar system. Normally, you would start with the load analysis, then size the battery on the amount of solar. This time, we know the amount of solar from the start. So we have to work backwards. When we look at the sun hours for Vancouver, we can see that we have several months over 3 sun hours. For the months without 3 sun hours, we will use a generator to recharge the battery. Using a generator will be cheaper than design the system for a minimum of 1 sun hour in December. So you will work with 3 sun hours. 5 kW of solar panels will generate about 15 kW hours of energy per day. To store this energy, you would need a battery with a capacity of at least 15 K hours for a 48V system. This can be achieved with 348 volt, 188 hour PowerSare batteries in parallel, each storing 5 kW hours. This battery capacity ensures you can store all the energy generated during the day to use when the sun isn't shining. Keep watching to figure out how much power we can use inverter and generator daily. In step 3, we will choose an inverter and a backup generator. The inverter will convert the DC electricity stored in your batteries into AC electricity that your household appliances can use. I recommend the Victron Multiplus 48 volt 5000 VA low-frequency inverter. Here's why. Low-frequency inverters tend to last longer. It can handle surge loads better, which is useful when starting appliances like refrigerators, pumps, or closet. It has a low idle power consumption of only 15 watts. It can work with a generator to recharge the batteries when solar power isn't enough. Let's size the backup generator. A generator can help recharge your batteries during cloudy days or long periods without enough sunlight. The Victon Multiplus inverter has a 70 AY input charging limit. I recommend the Honda 3000W inverter generator. Using 70% of the inverter's power output is recommended to increase fuel efficiency and reduce noise. Multiplying the generator output with 70%, we get 2100 watts. To figure out the maximum charging current, we divide the charging power by the charging voltage, and we become 36 AUMs. We can adjust the charging current from 70 AUMs to 36 AUMs in the Multiplus software. Using an MK3 USB dongle, it will take 7 hours to fully recharge a 15 kW battery with the generator. Stay tuned to find out what the system can run now. Let's talk fuses for our 5 kW upgrade solar system. If your panels are 50 FT or 15 M from the charge controller, you would need a 14 gauge solar cable as seen in this voltage drop calculation. Since there is no 14 gauge PV cable, we will use 12 gauge. The charge controller outputs 100 AUI-MPs. Applying a 1.25 safety factor, you would need a cable that can handle 125 AUI-MPs. Use 4-gauge welding cable which can carry up to 150 AUI-MPs. Install a 125 AUI-MP plus diffuse to protect the cable. The inverter will draw a maximum of 104 AE-MAGs. Applying the 1.25 safety factor, the maximum current is 30 AE-MAGs. Again, use a 4-gauge welding cable. And 125 AUM fuse. While the calculated current is slightly above 125 AUM fuse, the fuse will not blow at 130 AUM fuse, as we can see in this curve of the 120 AUM fuse consumption fuse. Now, many of you might ask what the system can run. First, we must figure out how much power we can consume. Daily updated solar design states you need 3 days of autonomy if we divide the battery total power of 15 kWh by 3 days. We have 5 kWh of energy consumption per day in this load analysis. We can use a fridge, a TV, several lights, a microwave, a freezer, and a computer. Lastly, we have to factor in the inverter idle power consumption. We become a daily energy usage of 4,600 hour. As you can see, it's not much for 5 kW of solar. Many people who order my solar review service have asked me to create a system like this for tiny houses or cabins. Let's break down the cost of this. Cost: 5 kW off-grid solar system, solar panels, $2,000 battery, $4,000, $500 charge controller, $11,000, $200 inverter charger, $1,000 $700 generator, $2,000 wiring, $400 fuses and breakers, $100. The total cost of this system is approximately $112,000. I have linked all the components in description from my recommended stores. Using these links helps me buy more solar equipment to test on the channel at no extra cost to you. If you want more upgrade solar diagrams like this one, check the first link in description or pin comments to get them for free with explanations about their sizing, including wires and fuses, just like this video. Do you have questions about the system? Let me know in the comments. Thanks for tuning in, and I will see you in the next one. I ask what the system can run. First, we must figure out how much power we can consume. Daily updated solar design states you need 3 days of autonomy if we divide the battery total power of 15 kWh by 3 days. We have 5 kWh of energy consumption per day in this load analysis. We can use a fridge, a TV, several lights, a microwave, a freezer, and a computer. Lastly, we have to factor in the inverter idle power consumption. We become a daily energy usage of 4,600 hour. As you can see, it's not much for 5 kW of solar. Many people who order my solar review service have asked me to create a system like this for tiny houses or cabins. Let's break down the cost of this. Cost: 5 kW off-grid solar system, solar panels, $2,000 battery, $4,000, $500 charge controller, $11,000, $200 inverter charger, $1,000 $700 generator, $2,000 wiring, $400 fuses and breakers, $100. The total cost of this system is approximately $112,000.